have to remember, if I'm playing a video and I hit record, I don't know how the YouTube police work, but they work crazy. So they found that and they booted me off the internet for like a week. I got pretty much. I went to the box for 2 minutes. I felt shame. Did somebody actually get that reference?
Yes. I do.
From what?
Oh, Despicable Me.
I was thinking it was like a general.
Could you explain?
I have the general
Slapshot? Nobody?
I like the general term for hockey.
It was.
No, wait, no. I heard
You
still
go to
want
box.
to watch that.
Anyway, logarithms. What's that? Good. What's this?
8.
Good.
Yeah, no, not the one that's like you think it would be 6, but
Ah, Izzy knows where I'm going.
What?
2 to what power is 6?
it's not.
2.5.
It's not Phoebe. We talked about this.
No, it is. What happens here is that logarithms allow us to figure out weird exponents. Okay? Logarithms and exponents are synonymous with one another. What happens here is that if you take the log
It's 5/2.
of a base 2, your calculators do this. Remember in that very first unit where we did some of the sequences and series stuff? We had like one little section where we did a log problem where you had to solve for the variable in the exponent. What happens is you can get the log of base 2 of 6 to tell you what this value is. It's not 2.5. It's not, I don't know what it is. Okay? Calculator does that. We'll get into why or how you set that up in a little while. What's happening here is that we're going to use what are called logarithms. And logarithms are basically this. I'll go back, no worries. Is that you have log of some base b of y equals x. And what this means is how you would set up the same scenario of b to some
You're kicked off the internet. And the scoreboard.
these two go back and forth between what's called logarithmic form versus exponential form. Yes, ma'am.
In the first one, is that like b to the y power, or is it just like b to the...
It's log base, this is kind of like what we call a subscript. It's log base b of y is x, is how that's read. Okay. So in that example that I did a second ago where we were doing log base 2, it was log of a base 2 of 6, that would give us some number. Okay.
Okay.
Is what this was saying. Now, what this looks like is this is logarithmic. And this is exponential form. And when we work with logs, they go back and forth between each other. Okay? They go back and forth between logarithmic and exponential, depending upon what you're working with. Now, I've said this before, is that when you're working with logs, it's a really nice. Oh, well, I'll do that tomorrow. It's a really nice, easy way of working with them. It's, like I said, it's log base b of y is x. B to the x is y. That's how these things go back and forth. Okay. So if we had log base 3 of y is x, that means x cubed is y. That's how these things set up. Okay. That's how these things are going to set up. You're going to find out that there are going to be some very easy logarithms to work with because logs can be simplified rather quickly because of some of the equivalent forms that they have. And we're going to go through a whole bunch of these things. We're probably only going to be working with this primarily this section for the next, I'd say probably about 2 to 3 days. Easy. Okay. Yes, ma'am.
How come it's not 3 Yeah.
Oh, B to, it's B, oh, did I flip it? I'm sorry. I'm sorry, yes, I'm sorry. B to the X. Snow on my brain. Because it's big, it's heavy, it's wood. This is the song.
Oh.
It's because of the song that got him kicked him off, so I was curious.
Just, no, it's fine. There are some special values that work with this. Log of 1. Think about what this means. The log of base B of 1 will equal 0 because B to the 0 is 1. Isn't anything to the 0 power 1?
Yeah.
That's how that works. Okay. Remember equivalent forms here. You've got log form. Here's your logarithmic form versus your exponential form. These two forms are equivalent to one another. They mean the same thing. Okay. When you have anything raised to a 0 power, it's always going to be 1. That's what it's telling you. Okay. Same idea of if your bases are the same, the log base B of B, that will always equal 1. And the reason that is because anything raised to the 1 power, the first power, is itself. That works all the time. That's how we set up that problem a little while ago when we were trying to solve for x in the exponent by taking that log base 2 of 2. It undoes itself. And that's how these things are going to work. It's very, very easy to work with these. Okay? When we get into the numerics of these things, there are a way of doing this in your calculator to type it exactly like that. Okay? We'll get to that when it comes up. There's also some very, a lot of times people will see this when they start switching back and forth between exponential and logarithmic form. So if I'm looking at log form of log base 2 of 32, let's do these one at a time. That's exactly right. In exponential form, that just means that it's 2 to the 5th is 32. Makes sense, right? Because we know it's 2 to the 5th power, right? Oh. All right. Same idea here. Log base 5 of 1 equals 0 because
5 to the 1.
5 to the 0 is 1. Oops. Log base 10 of 10.
10 to the first power equals 10.
10 to the first power is 10.
It's okay.
Everybody see how they coincide with one another?
Wait, so it's whatever's on the right side is the exponent? Okay.
Remember, how this works out is b to the x equals y.
Okay.
All right? That's how these work. Log base b of y is x. B to the x is y.
Okay.
Right? Log base 10 of 0.1 is negative 1. Think about what that means. It's 10 to the negative 1 power, right? Isn't that 1/10?
Okay. So do we use decimals with log?
You'll see, usually it's fraction. This is just one quick example. It's fractions or decimals they put in there. It's just showing that the exponent rules work, even with negative exponents. Which kind of is leading me here, you see how this is going to play into calculator, non-calculator. Because on your calculator, there's a log button, and it will do all of this for you. So if you didn't know what log base 5 of 1 is, you could press that in your calculator, and it'll tell you your answer is 0. But me being me, make you do this stuff by hand.
But what if it was like,
Then you have to stop there. Log base of a half of 2 equals -1.
2 to the -1 power. Half.
because it flips it?
1/2 to the -1 power is 2,
Oh.
because it flips it.
Wait,
Okay?
wouldn't it be true the other way though?
2 to the, yes, 2 to the negative, but then your base would be different. Your base would have been,
Yeah, I know. I just.
would have been log, it
I'm confused.
would have been log base 2 of a half is -1. It would have been that. Does that make sense? Okay? Not very, very scary, I'm hoping, right? How you do what? How you doing your calculator? I'll show you. If you guys go to your calculator real quick, I believe it is alpha window, and there's a button on there, number 5, it says log base,
Oh, that's how you get it.
and you can fill in the blanks. Now here's the difference, the log button versus the log base button. The log button that you have on your calculator is in a standard base 10. Okay? The log button on your calculator, just one that just says log, is base 10. Okay? If you wanted to change the base to something different, you hit the alpha window button. Does that make sense?
So log is like the lazy version, so if it's 10, you can just.
Yeah, well, back in the day before we even had this log base button, you had to do what's called change of base. And it's a very easy thing to do, but calculators didn't have it pre-programmed to do it this way. Everything was always done in a base 10 that you'd have to manipulate. When I was your age.
Oh my God, I had a conversation with the professor about that. I was like, I'm trying to help someone with math homework. She checked it and it was all right, and then he came back the next day and got an app on it.
Did you talk like that?
Yeah.
So take a minute, rewrite those into exponential form. All right. Let's take a look. I'm guessing this isn't that bad. What's the first one?
3 squares.
3 squared.
That was
What about the next one?
5 to the first power equals 5.
Next one?
1/2 to the second -2 power is 4. It was a team effort.
It was a team effort. It was something. And then lastly,
19 to the 0 equals 1.
okay. Well, it's just log. It's not that funny. Okay. Okay. Now what do you do?
So 9 to the half equals
And
11.
then plug it in.
That was
Thank
really
you.
beautiful.
So now we're going to start to do some of these by hand. Think about what they're asking you to do here. This is log form. If you switch it into your exponential form, you have 9 to the half power, which is 3. So your value of x is going to be 3. Okay?
He's going through.
Wait, what? Because this is where we're going. Oh, it's going to be 1/3.
Again, what you're going to ask yourself in these questions, if you have to figure out what the value of log base b of y is, you're asking b to what power is y? So 3 to what power would be 81?
4.
Wait, no.
3 to what power is 81?
Oh,
3 to 4.
4. What you're trying to figure out here is what's the exponent? What's going to be the exponent? Notice these aren't going to be problems that you're going to have to be able to, like what you're saying with using like a real crazy decimal. These are going to be problems that you should be able to do off the top of your head.
I don't know how to
Hold on
do
now,
it.
Sam.
Log base 5 of 0.04. Well, that means 5 to what power is going to give me, what is that, 400?
Oh, 1/25th. Oh,
Which is 1/25. 5 to what power is what is 1/25?
negative.
Negative.
-2. What they do here is they will give you sometimes a value in a decimal that you have to figure out. All right, 0.04, that's 4 hundredths. 1/25. Okay. 1/2 to what power is going to get me 8? -3. This is saying 1/2 to what power is going to get 8. Well, to turn a 2 into 8, you have to cube it. Since it's a 1/2, you just got to flip it, which means it's -3. Okay. And what's the last one? It's 1/2. Not -1/2, it's just 1/2 power, because 1/2 power is square root.
Oh, okay.
9 to what power is 3? Take the square root of it. Okay? Again, it's things you're going to be calculating out by hand. You're not going to use your calculator on these.
Wait, you leave it up for
Yeah.
I'm sorry.
We good? Michael, you all right?
Yeah.
All right. Of course, I forgot to run this on, so.
What is that?
I know. No.
Oh my goodness. I'll go on Saturday.
Oh, you know what? Let's just do it this way.
Saturday, you know, it's nice and cozy.
It's the girls. We have to do the art.
It's your band. Yesterday's orange. Orange? Were you in orange?
You guys were going here.
Maybe one time race.
Yeah, it's scrunchie face, we'll make sure you're all right.
Oh, I can't see.
Oh, put your glasses on.
They're not my prescription.
Oh. Why are you wearing? Oh, okay.
It's better to wear something than nothing, because if my contact goes in and I don't wear my glasses, I pretty much.
So far, so good?
What'd you get for
Okay.
2A?
Yes.
Nice.
Okay. I know, it's, trust me, this does get more difficult.
It does?
Oh,
Oh.
Yeah.
okay. Now, going the other way. Going the other way. B to the x equals y. So log base b,
3 is the base.
3 is your base. So it's log base 3 of y is 4.
Oh, that's easy.
Log base 3 of 27 is x. Everybody okay on that?
Yeah. No.
Log base 4
Yeah.
of, what is it, of m is 2. Do you need me to do the other ones?
Yeah.
Couple minutes for the last? Yeah, that's fine. Wait, I just put the last ones. The last ones are the ones I want to spend a little bit more. Oop, I don't know you're gonna do that. I want to spend a little bit more time on anyway. I'll just put these on a separate. see it a little bit better. I don't know, we'll probably get into, we might get a little bit of the graphing, depends on how far we go. We might wait to do graphing tomorrow. Graphing the logs is kind of weird. Let's check a couple so we don't waste too much time here. Now, I cannot stress it enough, the more that you write out what this is, the log base b of y is x, b to the x is y, the more you write that out, the better you're going to be at setting these things up real quick. So this first one is just 3 to the 4th power is x. What's x?
81.
81, good. All right. Next one is m to the 4th power is 81.
3.
What's m? X cubed is 1,000.
10.
Okay, we okay on that? Yeah. All right. There you go. Slowly but surely. So this is 2 to the 5th is x over 2.
64.
2 to the 5th is x over 2. What's 2 to the 5th?
32.
Times 2?
64.
You get 64. Everybody not see how we got that? 2 to the 5th is 32. Next one, we have 3 to the 5th is y. Well, we know 3 to the 4th is 81. Multiply that by 3. 243. And then lastly, 2 to the 5th is 4x. Why is this doing this? 8. Very good. Not so scary?
Yeah.
Until, right? Yeah, until. I think the last little bit of what we're going to look at here today is just what they're called inverses. I don't want you to write all of this top part out. I just want you guys to understand what's going on here. Basically what's happening is that exponential and log, the two that you work with like that, they undo each other. Here's what's happening. If you look at it like this, what they're doing here, let me move these down.
Would you write that?
I'm just going to show you what's happening. If you have log base 2 of 2, so 2 to the x equals x. Here's why. Since these two numbers are the same, the log base and the base of this exponent are the same, they undo each other. That's why that problem worked. That's why we were able to solve for x. We had that log base, or what was it, 2 to the x equals 6. In order to get this exponent to drop, you have to take what's called the log base 2 of that. By taking the log base 2, since these two numbers are the same, the exponent undoes itself when you get the log base 2 of 6 here for your answer. You're logging both sides. Okay? They undo one another. Same idea by using the exponents. If you have 3 to the log base 3 of x, see how this is a base? The log base 3 is the exponent. This has the same base as here. These two bases are the same. They undo one another. Okay? Exponentiating, I think that's what that's called. They undo one another to allow you to solve for x. by taking things to the same power to both sides. All right? It's a very easy setup as we get into these. You've already done this. You just didn't realize that's what you were doing when we did that one time. Okay? It's in how you undo. Just like undoing multiplication is dividing, just like undoing adding is subtracting, undoing square rooting is square. Well, to undo log, you exponentiate. To undo the exponentiate, you log. That's how they undo one another. They are inverses. Okay? Does that make a little bit of sense?
Yeah.
I think I have a very simple example here. I didn't want to get too crazy in this.
You said we're gonna spend a few days on this stuff?
Yeah. Yeah, let's go into what natural log looks like real quick. Once again, one of the things that they do here is, I think we touched on this a second ago, log base 10 is just written as log. Okay. Log base 10 is just written as log. They mean the same thing. So if you ever just see log of x, it is always implied that there is a base 10 there. That's the generic rule. If it's a base 10, they don't normally put the 10 there. If it's any other base, you have to know what it is. Okay? Now the other little bit here is if your base of the log is e. If the base of your log is e, that becomes what we call natural log. The log base e is called the natural log.
Wait, what does it say after?
ln, that stands for natural log. And your calculator, there should be an ln button. Probably somewhere around e. I think it's right under, it's part of, yeah.
Right under log.
See how natural log and e to the x are on the same key? Because e to the x, when you have log base e, you get natural log. Okay? The natural log stuff is the weird stuff. We don't touch a lot of it in here. You see, I think you see natural log more in chemistry, don't you? You guys have it in
I
chem.
don't know. We don't have it yet. They're not doing that yet.
I think you see it in chem.
Yeah, it's.
I think you see that in chem, but they use it a lot more in pre-calc. There's a lot more natural log stuff. It's not like it's a real difficult thing. It's just pressing buttons really a lot of times. It's all crummy numbers. So let me show you what we're going to do. We're going to simplify these things out. And this is, again, going to be something that we're going to be able to do without the use of a calculator. You see what we have here? We have 10 to the exponent of log of 2. What's the base of that log? 10. So this is the same thing as saying 10 to the log base 10 of 2. What's my answer?
Wait, were you simplifying it?
Yeah.
Oh, you simplified.
See how, do you guys agree that this is a base?
Yeah.
This is an exponent,
Yeah.
which means this is a base.
Yeah.
Are these two the same?
Yeah.
What happens to the 2? It just drops. These two bases are the same, therefore it simplifies to be 2. Yeah. Log base, when these two numbers are the same, if those two bases are the same, they undo each other, they cancel each other out. What if they're different, like in the next one? In the next one, you have log base 3 of 9 to the x. Well, can I change that 9 into a base 3?
Yeah.
How?
3 squared.
3 squared. So that's the same thing as log base 3 of 3 to the 2x. Do you guys agree on that?
Oh.
What does that simplify out to be?
2x.
2x.
So the log disappears along with 3.
What happens, again, these guys are, this base and this base is the same. If those two bases are the same, the exponent drops.
Okay.
But they're not.
Because you,
Then there'd be something where you can
Making
make,
the bases the same, that becomes 3 squared.
if it was just
For like
2
what if that was-
of log of 2,
Yeah.
then you can't do anything. Because this base is a base 10.
Oh.
You'd have to have a calculator, okay? Did everybody hear that question?
Yeah.
Let me repeat this. What Katie was asking, if you have 2 to the log base 2, I can't simplify that at all, because what's the base of the logarithm exponent? It's a 10. I can't, there's nothing I can do with this. Okay? It was just, I'd have to press buttons. What we're going to be able to do is work with stuff where it was a log base 2 of something. Okay? Then you'll be able to move things around. All right? Yes, sir?
Can you change like the big 2 to a different thing, like to make it?
Yeah. I don't think you see that as often. It's usually on the inside part, but logs are weird. All right. If I have log base 2 of 64, can you rewrite a 64 to be a base 2? What is it?
2 to the 6.
If it's something, and then
62 is 2 to the 6.
Yeah. It has to be the base.
like, if it's
Wait, 6. I don't know.
Then you have to do something up there to solve for that. If it was like log, if it was 2 to the log base 2 of something, it'll drop. They're not undoing. Write it down. There's nothing you're going to be able to simplify out of that. Because
I don't even know.
the same.
no, because that won't work. Because see how the log base is a base 2?
Yeah, but if it was,
It was log base 10.
yes.
And then it was, yes, the log bases, the base, the 2 bases have to be 2. Because if you look at this, in order for this to work, it has to be the log base 2 of 2 to the 6th.
Yeah. I got
These 2 values here are both, those are both bases. Once those bases are the same, the exponent drops. They have to be the same. And it works going the other way if it was like over here, where it's 10 log of 4. What's the base that you don't see?
10.
So this is the same thing as 10 to the log base 10 of 4. Since these bases are the same, this drops down, you get 4. Okay? It's just 4, yes, because it goes away. All right. Log base 25 of 5. I want to turn, I got to get that, excuse me, what's that? No, go ahead. So this would be log base 25 of 25 to the half.
So you have to make the big number the same as the
Because, again, this is a base, and this is a base of this exponent.
Why couldn't you make the log number?
You work with this guy.
Oh, okay.
Okay, you work with that one. All right? Log base 6 of 1.
Wait, so would it just be 1/2?
Yeah, just do 1/2. This,
Yeah, you didn't understand it.
wouldn't that just be 0?
Yeah. Why?
Isn't any log base, anything log base of 1? Remember what that means. It means b to what power is 1? 0. Okay? It takes a little bit of time to get used to some of these problems, not gonna lie. Yeah, but what is that?
Just 1/2.
It's just 1/2, because I changed that 5 to a 25 to the 1/2 power. Okay. Let's see here. I want to do.
No, I was only in that area, so
Wow, I didn't know this.
do you ever find out?
On your lucky day, you gotta take it out to be considered.
Wait, is that just all even?
Yeah, this is all the evens of this one, because I want to go, because I want to make sure that we get into a little bit more of the natural log stuff and working more with the inverses for some of the weird ones in a minute, okay? So we'll start out with those. Try not to use your calculator. For a lot of these, you shouldn't need it, okay?
That pink sheet.
Start thinking about what does it mean. We'll get into it. What is life? What is love? Just don't hurt me.
Don't hurt me.
But only 28 from 60?
I think I've answered that question.